Hello student, today we'll be solving the IB Math A HL May 2025 paper 2 times on 3 question number 10. You will be getting the solutions for the first 9 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math A HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 10. The maximum mark is 14. Two athletes, Fiona and Lucy, compete in a 200 meters race along a straight track. Fiona's velocity in meters per second during the race can be modeled by V of t equal to 8.14 t divided by square root of t squared plus 0.2, where t is greater than or equal to 0, and time t is measured in seconds from when the race starts. Part A is having two further subparts. The first subpart I is saying find the value of V of 1. That means time is 1 second after the race started. Okay. So A and I, V1 is equal to 8.14 times 1 over square root of 1 square plus 0.2. Okay. So we will be using the calculator. 8.14 times t, that is 1, which is equal to 8.14, divided by this one is 1 square is 1, 1 plus 0.2 is 1.2. Okay. So it is square root of 1.2. Enter. 7.43. Correct to 3 significant figures, it is 7.43. Okay. So equal using GDC. V of 1 is equal to 7.43 meters per second, 4.73 meters per second, correct to 3 significant figures. Okay. I find the time when Fiona's velocity is 5 meters per second. So I 5 equal to 8.14 t over square root of t squared plus 0.2. This is an equation. We have to find the value of t. So I'll be using the insolve. You can graph. You can graph this part separately and y equal to 5 separately, and you can find the intersection points coordinates, or you can graph the expression 8.14 t divided by square root of t squared plus 0.2 minus 5 and get the zeros. But I'll be using the insolve. Okay. So calculator and menu, and then number 3 algebra, and number 1 numerical solve, insolve. So 5 equal to 8.14 times t over square root of t square plus 0.2. Okay. And now I have to declare the variable. So it is t. And I come out and I can give the condition t is greater than or equal to 0. So I have put this vertical line, the pipe, and then t, and then again control and equal to and greater than or equal to 0. Enter. 0.348. Okay, 0.348 seconds. So again using GDC, I'm not writing it. So t is equal to 0.348 seconds correct to 3 significant figures. Okay, fine. Coming to subpart B. Find the time when Fiona's acceleration is 4 meters per second square. Okay, so acceleration, we are given the velocity expression. So the first derivative of the velocity expression will be giving us the acceleration expression. So therefore, acceleration A of t is equal to dv dt. Okay. So therefore, 4 is equal to d dt of the velocity expression, that is 8.14 t over square root of t square plus 0.2. Okay. So again, I'll be using nsolve, menu number 3 algebra, and number 1 numerical solve. 4 is equal to d dt. So I'm coming over here, the button next to 9. So this one is, sorry, this is the second derivative. The first derivative is this. Okay, and it is d dt. And now the velocity expression, 8.14 times t over square root of t square plus 0.2. Okay, and comma, not inside, outside this. Okay, and comma and t. And again, I am giving the condition, t is greater than or equal to 0. 0.591 I am taking correct to 3 significant figures because it is 0.5909. So 0.591. Okay. So therefore, t is equal to 0.591 seconds correct to 3 significant figures. Okay. Part C, it is having two further subparts. The subpart I, the first one, write down the limit of v of t as t approaches infinity. Okay. So, Ci limit t tends to infinity, v of t is equal to limit t tends to infinity 8.14 t over square root of t square plus 0.2. Now, t tends to infinity, that means it is a very large number, very, very large number. So, adding this 0.2, so t is as such a very large number and it is getting squared. So, you can imagine how large this is. So, adding 0.2 is not creating any difference. This 0.2 is very, very insignificant as compared to the magnitude of t square. So, adding 0.2 to t square is almost equal to t square. Okay. So, this is limit t tends to infinity, and if I write t square plus 0.2 as t square, what do I get? It is almost equal to, because 0.2 is really almost equal to 0, means it is nothing in comparison to t square. Okay. So, it is t square. And this is equal to limit square root of t square is t. So these two will be getting cancelled, and so the limiting value is 8.14 meters per second. Okay. So limit t tends to infinity, v of t is equal to 8.14 meters per second. Okay. So I state a reason why the value in part CI is not valid in the context of this question. Now you may give, there are actually more than one reason, but we are supposed to give one reason, only one of them. And the very first reason that is coming to my mind is t tends to infinity, and this is a race. So the time is a finite time. It is not an infinite time. A race does not complete it completes. So the time is fixed. It is limited. It is not unlimited. It is not moving up to infinity. Okay. So we can say that since it is a race, the time approaching infinity is not practical, not feasible. Okay. So we can write, since it is a race, therefore time approaches infinity. Approaches infinity is not realistic. Okay. Lucy's velocity in meters per second during the race can be modeled by W of t equal to 8t over square root of t square plus 0.3, where t is greater than or equal to 0. Fiona completes the race and crosses the finishing line in front of Lucy. So we do not know how many competitors are there, but between Fiona and Lucy, Fiona is winning. So subpart D, find the distance Lucy is from the finishing line when Fiona completes the 200 meters. Okay, it is carrying 6 marks. So distance from the finishing line. So we have to first, because we are given the velocity, we can find the displacement, and since it is a straight track, so the displacement will be equal to the distance traveled by Lucy and of course Fiona. So we can find the distance traveled, but in what time? We have to find the time first. And the time is the time needed by Fiona to complete the 200 meters. Okay, so we have to find the time that Fiona takes to complete the 200 meters. Okay, so again, I'll be using the nsolve. So first of all, let us write the equation. So for Fiona, 200 meters, it is the distance, and the velocity expression is given, so it will be the integral to get the distance or displacement rather, and it is, we have to find the time. So the upper limit, the starting value of time is 0 seconds, and we have to find this t. Okay, so the upper limit is t, this you have to understand, and the expression v of t was 8.14 t over square root of t square plus 0.2 and dt, and we have to find the value of t. It is meters. We do not write the unit in an equation, so it is 200 equal to this. And now the calculator. Again nsolve. Okay, and 200 is equal to integral, lower limit, lower bound is 0, upper bound is t, integrand 8.14 times t over square root of t square plus 0.2 and dt. Okay, and fine, and comma and t, and again the condition t is greater than or equal to 0. Okay, fine. So we have got the value as approximately, because this is not the final answer, I'll not be taking only 3 significant figures. So I'm taking 25.01324, I'm taking, okay, 25.01324. So therefore t is approximately equal to 5.01324. Let me check once more. 25.01324. Okay. And using GDC, of course. So this is the time taken by Fiona to complete the race. And now we will be finding the distance traveled by Lucy during this time. And the Lucy's velocity expression is this: 80 over square root of t squared plus 0.3. Okay. So now Lucy, we have to find the distance traveled is equal to, now we know the time interval. It is from 0 to this. The upper bound will be this one. 0 to 25.01324, and it is 8t over square root of t squared plus 0.3 and dt. Let me check once more. 80 and this, right? So now we have to find the value. This is a definite integral, so I do not need any n-solve now. So it is just this one and 0, and this I can take as the answer, and the integrand is 8t over square root of t square plus 0.3 and dt. Okay, enter. 195 point, okay, I'm taking 195.77, okay, 195.77 meters. So equal to 195.77 meters in 25.01324 seconds is 195.77 meters. Okay. So question is, distance Lucy is from the finishing line. So therefore Lucy is 200 minus 195.77 or meters, or 200 minus, it is the answer. It is 4.23 I am taking. Okay. So 4.23 meters from the finishing line. Okay. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving question 11 of the same paper. Till then, bye.